Okay, I've already gone through a few examples of finding relative extrema, but procedure 3.1 kind of walks you through all the steps. So you're supposed to find the derivative, locate the critical values of f by setting the derivative equal to 0 or looking for what's undefined. And then you test the intervals for their signs, or test the intervals, the derivative, the sign of the derivative on each interval. And then you use the first derivative test to decide whether each critical number is a relative max or a min, or neither. So now, for example 3.6, what we're doing is we're taking the derivative, and then you're going to set it equal to 0 to solve for the critical numbers. We don't need to look to see where it's undefined because the derivative is a polynomial, so it will always be defined. So you solve and you get 2x times 2x squared minus 1 equals 0. So either x equals 0 or x squared equals plus or minus square root of 1/2. So these are your three critical numbers. And we need to figure out when these correspond to a max or a min. And in the previous set of videos, we already kind of looked at this function. So we know that it looks something like this. And we figured out that it was decreasing and then increasing and then decreasing and then increasing. So let me just say decreasing here and here, increasing there and there. And so we know that the x equals negative square root of 1/2. That's going to be a relative min. And that's because it goes from decreasing to increasing. And then x equals 0 will correspond to a relative max. And that's because the function goes from increasing to decreasing. And then finally, x equals square root of 1/2 will be a relative min again. And again, it's because it's going from decreasing to increasing there. And so the takeaway here is just that you can use the derivative to figure out whether or not a critical number or critical value is going to be a maxima or a minima, just by looking to see if the derivative goes from negative to positive or positive to negative.